Hello everyone, you are all welcome to lecture number 1257, and today's topic is the kinetic requirements for organic reactions. In previous lecture I have already discussed the thermodynamic requirement. So it is not necessary that once any reaction is fulfilling its thermodynamic requirements will proceed, because there are lot of reactions where thermodynamically they are in favor of taking part in reaction and converting into product, but they are not going under reaction. For example, oxygen and hydrogen in our atmosphere. So once oxygen and hydrogen, when they react together, for example, oxygen plus hydrogen, you will get H2O, and delta G will be minus. So according to thermodynamic requirement in the atmosphere, this oxygen should combine, should explode with hydrogen, and there should be formation of water. But it is not happening. Whatever condition is fulfilling, that is theoretical condition. If I ask anybody whether in atmosphere oxygen and hydrogen will form the product water, everybody will say no. It's not possible. Never, it will never happen. That is the experience. And sometimes experience supersedes your theory or your requirement. So in the case of oxygen and hydrogen in atmosphere, if there was no need of kinetic requirement, they would have been exploded, and everywhere we would have got the explosion, combination of oxygen and hydrogen, and even that spontaneous reaction would have been there. But no, it will not take place. It is only possible when it is fulfilling its limitation of kinetic requirement. So kinetic requirement means it needs some energy of ignition, that is called activation energy, energy of activation. It is called energy of So unless this much of energy of activation is supplied, only then the reaction will take place, and that requirement of energy of activation is called the chemical kinetic requirement or kinetic requirement of any reaction to take place. And here the reactant, either it is ignited by supplying the energy, or by catalyst, or by some ultraviolet, infrared heat. By any means, you have to supply to activate the reaction, only then it will proceed. And there is energy of activation. There is one graph like this, so that if there is product, for example, there is graph. So here it is reactant and it is product, and it is energy. So what is happening here? It is your reactant. So once you supply some energy, that is EA, energy of activation, then it will climb the hill and it will reach to the top of this hill, that is called transition state. So why I am showing this, and only then it will roll down to product. So why I am showing this graph? Because if suppose you are supplying some little energy or you are igniting and that is not sufficient for this reactant to reach to transition state, reaction will not take place. Unless it reaches to transition state, and once it reaches there, automatically it will roll down to product. So that is the requirement. So in this case of water, the kinetic requirement is limited and is not fulfilling, only it is fulfilling the thermodynamic requirement. So for any organic reaction to take place, it is a must, it is necessary that thermodynamic as well as kinetic requirements should be fulfilled, and if there is any limitation of either thermodynamic requirement or kinetic requirement, the reaction will not proceed and it will not form the product. And the second example is when we are going for photochemical reaction. So in the process of photochemical reaction, during that process there will be unequal breaking of bond. So like this, CS3 is there and bond breaking will take place. You will get, that is called methyl free radical. It is your methyl and another methyl free radical will combine together and there will be polymerization, means one monomer will be converted into two monomer and you will get the product CS3. That is your ethane. So the combination of two methyl free radical and to form the product, it doesn't require any energy of activation and it is already having enough kinetic energy, or kinetic requirement is fulfilling, and it is infinite whatever free radical is produced, because there are so many factors like collision, like energy of the molecule, that internal energy that I have already discussed. So these factors are, if they are energetic and if it is high, in that case there is no need of any energy of activation or any to ignite it or to put any catalyst. For example, hydrogen to combine with oxygen when it is hydrogen cell, in that condition, in presence of catalyst, platinum, that will accelerate the reaction and there will be formation of water. Unless there is catalyst, platinum, to accelerate the reaction, there will not be formation of any water. And I have already told you that it is fulfilling the condition of thermodynamic requirement. So here I have summarized to write down So number one, as we know, the negative value of Gibbs free energy that is delta G is necessary for the reaction to proceed into product. This is the basic principle of that is thermodynamic requirement, that if delta G is negative, there will be formation of product, it will proceed, reaction will proceed into product, but only change in Gibbs free energy, that is delta G, is not sufficient condition for an organic reaction to take place. So this is very important, that once it is fulfilling the thermodynamic requirement, doesn't mean that the product formation will be there and organic reaction will take place. For example, in the case of hydrogen, H2 in gaseous form, oxygen in gaseous form, and then there is formation of water in liquid form, where the delta G is highly negative. So it shows that immediately there should be explosion in the air and oxygen and hydrogen should combine, because it is fulfilling the thermodynamic condition, but it is not happening. So delta G in this reaction is highly negative, and do you think the hydrogen gas would burst into flame at room temperature, where we are sitting maybe 25 or 30 degrees centigrade, to produce water molecule? It is not going to happen. And even if you tell anybody out of experience, they will say big no, because experience is more authentic than some theoretical experimentation. So number two, the answer is big no, and never. It is our experience will never be around. It means that just fulfilling the delta G value less than 0 means it is negative criteria to start the reaction is not enough for reaction to take place. There must be some other requirements as well, and that other requirement is nothing but kinetic requirement, that is called energy of activation. Number three, the reactants must be supplied with energy of activation to cross the energy barrier in the path of the reaction. That energy barrier, I showed you the hill and down the hill, that graph, that reactant, when you ignite it, supply some energy, it is activated and it will start climbing and it will reach transition state. Unless it is reaching transition, if energy is less, it will not be changed into product, it will again come down. So once it has crossed the transition of the hill, then it will roll down into product, and that amount of energy which is responsible of taking it to transition state and converting into product is called energy of activation, and that energy of activation is nothing but it is kinetic requirement or kinetic condition that is responsible of the rate of the reaction, that reaction will take place. And here the barrier into the path of the reaction, this is called the kinetic requirement of chemical reaction. So point number 4, now it is clear that collisions among the reacting molecules need not necessarily give rise to reaction to occur. So collision means entropy change. If there is lot of randomness, lot of collision among the ions, atoms or molecules of the reactant, means there should be a reaction is not necessary to occur. That is the reason why we, along with other matters, have surrounded in oxygen-filled atmosphere without undergoing spontaneous reaction. That is the reason that oxygen can catch fire, and it is surrounded with lot of different type of gases, atoms, ions, and it is stable. Is because of the kinetic requirement, kinetic factor. Undergoing spontaneous combustion is not undergoing. A mixture of reactants may be thermodynamically unstable. Any reaction may be unstable from thermodynamical point of view, but kinetically inert. If it is kinetically inert, means it needs activation energy, enough activation energy to push it to reach to transition state, to roll down to product. Reaction will not take place. Inert with respect to product formation. So here example is two methyl free radicals. They are combining and it is irreversible reaction, and the product is formed, that is ethane, and it is irreversible condition, and it doesn't require any kinetic requirement or energy of activation. This is the reaction of zero activation energy. It doesn't require, and it will take place. And the equilibrium constant KEQ of this reaction is infinite, and dimerization is perfectly irreversible. So with this I will stop. Thank you very much for watching the lecture.